Hi everyone, Mrs. McBain here. Today we're going to be learning about factoring expressions and distributive property. So let's jump right in and see what we're doing. So our first problem here says prove that 3 times a plus b is the same as 3a plus 3b. And we've got a hint. Give the letters a value. Okay, so it looks like we are working with our distributive property first. So what that tells us is that we want to take this 3 here and multiply it by a. And just like you've heard me say before, whatever you do to one side, you have to do to the other. So then we're also going to multiply the 3 times b. Now, because we don't know what a and b equal, we can't really go any further than 3a plus 3b unless we give the a and b a value. So let's do it. So let's see. So that would give us 3, and then let's keep it a nice and simple value. So we'll say 3 times 2 plus 1. Okay, so let's go ahead and write that out there. And so that would mean if we were to do the addition and multiplication, we would start by doing 3 times 2. So 3 times 2, well, that's of course 6. So now we've got 6 and then 3 times 1, because remember, whatever you do to one side, you have to do to the other. So 3 times 1 is 3. And that gives us 6 plus 3 to equal 9. Okay, so that's what it would look like if you gave these letters right here, this A and B, a value of 2 and 1. You'd be able to prove it by showing that problem right there. All right, let's see what else we have going for us here. Let's see. All right, so here it says use the greatest common factor and the distributive property to write equivalent expressions for the following expressions. Okay, so remember, when we're writing something that's an equivalent, we're going to be writing something that equals the same thing. Okay, so the first thing we have to do is find our greatest common factor. So remember, our greatest common factor, I'm sure you remember from a while ago, I did a video about finding your greatest common factor by using a Venn diagram. We're not going to go into the full Venn diagram today, but let's go ahead and take a look and break these down into their prime numbers. Okay, so we'll start with the number 18. So the 18, let's see, we can take that down to, let's go with 2 times 9. So put our 2 there and our 9 there. Now, of course, 2 is a prime number, 9 is not. So you break that 9 down into, let's see, we'd say 3 times 3 to equal 9. All right, and so those are all prime numbers, so we don't need to go any further. And then let's take a look at the 30. All right, so the 30, let's see, let's keep it nice and simple. How about we say for the 30, how about we say 2 and 15? That sounds nice and easy. So we'll say 2 and 15, because 2 times 15 equals 30. Now, of course, the 15 is not a prime number, so we do need to break that one down. And let's say for 15, we could say 3 times 5 to equal 15. All right, so now let's take a look at our numbers. Do we see any numbers in common? Oh, we sure do. We've got a 2 here and a 2 here. So let's circle them, draw a line that way we know that we've used it. We also have a 3 here and a 3 down here. So we're going to circle those, and I'm going to come all the way around. All right, are there any others? Looks like after that, we are just left with the 3 and 5. So we have one set of 2s and one set of 3s. So to come up with our greatest common factor, we're going to multiply 2 times 3. So multiply 2 times 3, and that's going to equal 6. Okay, so that's going to make this problem. So let's see. So we could say 6. Now remember, we've got to use our parentheses. So 6 times, well, 6 times what equals 18? Do you remember? What times 6 equals 18? Let's see. So that looks like that's going to be 3. So 6 times 3 equals 18. So 6 times 3a. And, oh, we need a plus sign there. And so what times 6 equals 30? Well, 5. So we could say 5b. So that is how we're going to expand it out using our distributive properties and using our factoring on the expressions to come up with 6 times 3a plus 5b. All right, so let's take a look at the next one. Let's go ahead and erase some of this up here so that we've got some room to work. And we'll get rid of those numbers. All right, almost gone there. All right, so let's go ahead and take a look at our next problem. So our next one, it says 4x plus 12h. 4x plus 12h. Let's take a look and see what we can do with that 4 and that 12. All right, so we're going to go ahead and take a start here with our 4. So let's go ahead and break that 4 down into its primary numbers. So 4, so we can say 2 times 2 to equal 4. And let's go ahead and take a look at the 12. Oh, wait, I'm sorry. 2 times 2 to equal 4, not 2 times 4. There we go. 2 times 2 to equal 4. All right, and so let's go ahead and take a look at the number 12. So the number 12, we're going to break that down into its prime numbers. And to break that 12 down, we could say, let's see, we could say 3 times 4 to equal 12. All right, and of course the 3 is a prime number, but the 4 is definitely not. So let's go ahead and break that down a little further. And so we'll have 2 times 2. All right, and now that we've got all of those numbers down at the prime numbers, once again, now it's time to take a look and see which ones we can match up together. So I've got a 2 here and a 2 over here. So those definitely match. Let's draw a line between them so we know that we use them. We've got a 2 here and a 2 here. So those match. So we'll draw that line as well. All right. And so we do know that, of course, 2 times 2 is going to equal 4. Okay, so that 4 is going to be our greatest common factor. Okay, so we're going to come over here. We're going to start writing out our problem. So we've got 4 on the outside. Now, 4 times what equals 4? Well, 1. Now, do we really need to put the 1? You could, so it would look like 1x, or you could just leave it as x. Okay, so you can do that either way. So either 1x or x. And then we're going to be adding to it. And let's see, and so 4 times 3, we said, equals 12. So we'll go ahead and put the 3 there and our h next to it. Now, if you're wondering why does that work? Well, that's because we are expanding this out into its distributive property using factoring expressions. So that means that we are saying that 4 times x equals 4x, and that 4 times 3h equals 12h. Does that make sense? Okay. Well, let's go ahead and get rid of some of these numbers again. All right. All right, so let's see here. Okay, so the next set that we are working with are 24 and 56. So let's go ahead and start with the 24. So we'll go ahead and break that down into its prime numbers. All right, so there's our 24. All right, let's go ahead and keep that nice and simple. So we'll say 2 times 12. All right, and of course, 2 is a prime number, 12 is not. So then we could say, let's see, 2 times 12. So we could say 2 times 6 to equal 12. And let's see, 2 is that prime number, but 6 is still not a prime number. All right, so let's go ahead and break that one down. All right, and so we could say for that 6, we could say 2 times 3. All right, and there we are. We're finally down to our prime numbers for that one. Let's take a look at the second number, which is 56. All right, and so let's go ahead and break that 56 down. Oh, I do apologize. It looks like my microphone turned itself off for a second. So 56, we're going to break that down into 2 times 28 because 28 times 2 is going to be 56. And now let's go ahead and break that 28 down. So let's see, 28 broken into 2. So we're going to have 2 times 14. All right. And then we'll break that 14 down, and we can break that 14 down into 2 and 7. All right, so now that we've got our prime numbers there, let's go ahead and start taking a look and see if we have any in common. All right, I definitely see some here. So let's see, so we've got a 2 here and a 2 here. So we're gonna circle them, draw a line. We've got a 2 here and a 2 here. So circle them and draw a line. And oh my goodness, another 2. So another 2 there and a 2 there. So circle them both and draw a line. So I've got 3 sets of 2s. Okay. Now remember though, when we are doing factoring like this, we need to make sure that we are not saying 2 times 3 because we have 3 sets of them. We want to make sure that we say 2 times 2 times 2, okay? And that is certainly not 6. So let's take a look at that here. So we have 2 times 2 to equals 4, and then 4 times 2 to equal 8, okay? So be careful when you do that. Make sure to do the math correctly. Okay, so that means that when we come over here, we're going to go ahead and write down our 8 because that's what we're going to start with. Now, 8 times what equals 24? Well, that's 3. So we'll put our parenthesis. We can write 8 times 3g plus, let's see, the 56. Let's see, how many times does 8 go in there? That's going to go in 7 times. So 7e. Okay, so do you see how that works there? So we are saying here that 24g plus 56e is the same as 8 times 3g plus 7e, because whatever we do to one side, we have to do to the other. So we are multiplying our 8 times 3, and then we're multiplying our 8 times 7. And so remember, 8 times 3, 24, 8 times 7, 56. All right, so let's get this last one done here. So let's go ahead and get some of these. Oh, I did not want to erase that one. There we go. Get some of these numbers here out of the way. We'll get it all cleaned up, and then we'll do our last one. All right, so let's just make all of that go away. There we go. All right, so looking at our last one, we have 28 and 21. So let's go ahead and work on factoring out that 28 first. Oh, that was a little long. All right, so 28, so let's see. So we could say 2 times 14 to equal 28. Now, of course, 2 is a prime number, 14 is not, so let's keep breaking it on down. So let's see, so 2 times 7 to equal 14. And we are done right there with the 28 because those are all prime numbers. Let's go ahead and take a look at the other number, which is 21. All right, and so let's see here. So looking at that 21, let's get a line down there. All right, and let's see here. And so with the 21, let's see, we could say 3 times 7 to equal 21. All right, well, let's take a look and see what numbers do we have in common. And we'll go ahead and get those circled. All right, well, let's see, there's no 2s, no 3s, just the number 7. Okay, so we've got just one number 7. So that's all we need to write is just the number 7. So our next step here is going to be is going to have us trying to figure the rest of this out. So this is going to be 7 times what to equal 28? Well, 7 times 4 equals 28. Don't forget your letter M. So 7 times 4 to equal 28, and then we need 7 times 3 to equal 21. So we'll type in our 3b. And now you can see that we have our distributive property by showing that 7 times 4, which is 28. So there's our 28m right there, and our 7 times 4. And 7 times 3, which is 21. Okay, so there's our 3b right there, and there's our 21b. All right, so that is factoring expressions using distributive property, or I'm sorry, distributive property using factoring expressions. If you do have any questions, feel free to leave a question in the comments, and I hope that you all have a great day.